Good evening. My name is Ayo, and it's my pleasure to be here. I'm happy to meet everyone. I'm very excited to meet people, and I realize lots of people love Golang Calgary. We just don't know each other. Because many people are just behind the system for 3 years, 4 years. It's not like me, but very happy to be here. And today I'm just going to talk about something. It's going to be very, not very less formal. I hope that's okay. Yeah. There's no metric. There's no line. Nothing like that. So yeah, I'm just going to walk through the projects, just to share a couple of things with us. And the title is what I titled. You see my screen for just a minute. All right. So from vibes to metrics. Talk. And the part of what there, I'm sure you're familiar with vibes. Right? So there's vibe and there's vibes. So there's vibe coding. What are the other vibes that we have? Does anybody vibe tested? Vibe what again?
Vibe deploying.
Vibe what?
Deploying.
Vibe deploying? Yeah. That's it. Yeah, there's a lot of it. There's vibe monitoring. Where you just tell the AI, give me the Grafana dashboard and make sure it's all great. That's vibe monitoring. So just going from vibes into metrics, because we all know that the cost of generating code will go to zero. It's cheaper, it's getting cheaper. Even non-technical people, they start together and they build stuff. And I've seen that firsthand. Friends that are very smart, and they build a whole application. And when I saw it, I said, okay, this would have taken me 6 months to build 10 years ago, and someone is doing it in 3 weeks. Yes, we can talk about quality, all the things that you do. They might not have that, but they have the working product. And at the end of the day, customers don't really care about the code. Mm-hmm. Yeah, you and I care. They don't. What customers care about is a working application. As long as it works and it does their job. So I'm talking about how to build a test mechanics for LLM application. And I believe that a lot of people are doing LLM application. Is there anyone who hasn't built an LLM application so far? Because everybody puts AI into their product now. Mm-hmm. If you never build an AI product, now it's an AI product. And so we look for AI features, anything you can do to put AI in the name. People can't even change their name to Photoshop AI, just to get in the vibe, and that's all good. So I'm talking about just going through. So about this talk, this is an AI-powered domain-specific agent that answers complex questions. And yes, the whole concept is, and I'll tell you what domain it is. It's a financial domain. So he's able to answer questions from structured filing, company publication, all of this document that regulators ask for that companies have to give every year, public companies. So their financials, their data, the livestock, and also it should also be able to respond with citations. Meaning, if you say the stock price of Google is $200, you need to tell me the reference where you found it. That was one of the requirements. And the reason. Because LLMs can be very smart. They tell you that Google share price is $1. Right? And you're going to say, are you sure? To say, yes, I'm very sure. So we can't trust LLMs that much. So we need to do something like this. And the problem is, how do you know if it actually works? It's a large domain, tons of data. You could do manual testing, which is great, but that also kind of like limits you because it's too much things to test. So, and we had this kind of problem, and I decided to, let's see what helps, what better way can we solve this. So we did something called enhance, and I'm just going to walk through that show. Yeah, so I talked about this already. So like you said, there's vibe testing, there's also vibe-driven development. Yes, there's vibe deployment, vibe monitoring, maybe even vibe hacking. Where hackers just be like, go and hack all the vibes, right? And then, we've also seen vibe layoffs. Yeah, where execs just be like, you know what? Because of AI. Do you need money? No. Do you have a problem? No. Do you have too much elegance? No. Why are you laying off AI? That's vibe layoff. Because the fundamentals are really not there. But there's pressure. And I get it. So vibe is great until everything starts to break. And I'm sure we've experienced that. And I said at some point, every company must decide, are we building software or just managing vibes? At some point. So we want to build real software, which is what we've been doing before this vibe came. And the truth is, a software will always be a software. A good one will be a good one. So, and that's the good thing, about our craft. Our craft, and we put the best in it. And that's why an application built by, a senior backend engineer will be different from the vibe we have in the weekend. They might do the same, they might even do the same. But at scale, things get tested. Right. All right. So when we have an agent to question, we can read the answer and be like, yeah, that's right. Let's cheat it. But that's not correct in this kind of domain. Integrity is at stake. We don't want our agent misleading people, telling them a particular stock price that's incorrect, and they believe that and take actions because of that. So there has to be a baseline, there has to be repeatability. We have to be able to run the code again and again and generate the same answer. And if you know the way LLM works, that's pretty hard. If you can argue well enough, LLMs will agree that the sky is red. You just have to tell them that's red. It's going to say, apologizing, sorry, it's actually red. So, we can't bring that into the system for people to use so that they can trust. So I'm just going to go through so what we needed was something like that's repeatable, something that can categorize like our question. As we ask the agent question, we want to put them in categories. We also want to score them to know whether the agent actually got the right answer or not. And we also need this to run fast. So otherwise, we'll be here testing for months, which we don't have that time. So that's the goal of like what we're looking for. So this is not the architecture of the app. It's just for the apps. So there are test cases written in simple JSON. Each of those test cases, they will call the eval, the data tool. And then that panel we talk to the actual chat agent, the one we're giving to customers. So you're going to send the question to them, get the answer back, and then call an LLM, and then try to use what we call LLM-as-a-Judge. But there are caveats. The LLM will be able to check, and then we have a score and a report at the end of the day to say, did this agent answer this question correctly? So in this case, we use test cases that we have already validated, not generated questions. So questions from like real life, where we actually go check the share price of Google, as at that time, or we check FY revenue, 2024. Then we have all those questions as a set, and then we run this analysis and try to look through all of the questions, and then grade them. So I'm just going to show us what we've done. So this is what it looks like. We have the idea of the category, the question. So, and I'll tell you what problem we have here. So what was the total revenue, for example? This is our expected answer. Then we have some kind of tolerance because LLMs will not always say the same thing all the time. So we have to allow some tolerance as long as the semantic meaning is correct. We cannot allow that. But there is something we cannot play with, which is the numbers. Because 281.7 million is different from 281.7 million. Lots. Right? So and LLM doesn't know the difference sometimes. He's able to hallucinate and come up with things. So we have to be very, very explicit with the numbers so that they do exactly what we're trying to say. Okay, so that's just a simple JSON, nothing complex, just to give you some idea and then question and answer. And this is just like a regular test case, just a regular test in any kind of program. Anyways, okay. Then the tolerance mode that we have the exact one where we're like, you know what? Give us exactly the number. Anything else is incorrect. Or you can give us some contains some kind of factual impulse that we can still live with. And then there are sometimes you can say something else that's different as long as the contextual meaning is the same. That's kind of acceptable. So and then based on this we now have score it and put it okay, if you give us the correct answer, we want to give you a particular score. If your semantics is close, we also want to create some score there. And at the end of the day, we can see how our LLM is performing. So the second concept is the LLM as a judge. And this we're using GPT-4 meaning here because of course. Right. Why is the laptop my bottom? It's spending too much money. So for the LLM as a judge, we're literally looking for what was the diluted EPS, then we send the expected and actual to the LLM. Okay, look at this two. Tell us if this is what's all correct, if the reasoning is also correct, the reasoning of that answer. So that LLM is able to tell, okay, this is the question, this is the answer, this is the expected, this is the actual. The three LLMs, this will happen on our machine. It also does cost us money then. It's just too small to notice. It costs maybe 0.0000000. But now we have to spend for all of this, even to validate what we're doing. And there's a reason we have to do that. So if we score over 0.7, we give it a pass. Anything below is fail. We didn't want to go below. We don't want to make the bar too low. Otherwise, LLM starts telling us what's not true. So, and this LLM as a judge concept really helps out to do that. So this is the other part where it gets interesting is we have questions that are just text. For example, who is the CEO of Shopify? When did they retire? If he has retired, those kind of questions. And there are some questions that they are actually in a financial table. And if you've done anything around that, you know what table I'm referring to, where you get all the tables of the financials. And you needed the LLMs to also, you needed the agent to also understand that table. And be able to answer questions from it. And there's one more question that we wanted the agent to be able to answer, which is a question like, if I bought the share of Google 10 years ago, how much would I have made by now? Very simple question, but very complex for the LLM to calculate. Because it needs to look at the current share price, it needs to look at share price that 10 years ago, and then do a bit of a calculation, which you also cannot risk hallucination on. Right? So yeah, so we wanted that kind of calculation as well. That result. So when we had a first run or the early runs, we had something like this, where we can say the table questions are not fully correct. The text questions are doing great. So how did we make the text question do great? Obviously, I think with we're running retrieval augmented generation. I'm sure everybody's familiar with it. Right? It's almost like the plots in a way. So, and then another thing we didn't do is to trust numbers to LLMs. Because if you trust numbers to LLM, it might manipulate, it might answer. So what did we do to that? We store the numbers as regular tables. Just create tables and put the numbers inside. And when you need an answer, you just run a query, your regular SQL query to match the number. And you send that to the LLM to compose the answers. So that was like not a trick really, but if you throw numbers to LLMs, it's likely to run. Especially when there's a lot of numbers. So text versus table. So when we ran this harness, what we quickly found was that our text tables was very good, but our text was very good, but our table was really messed up. And this was something that was very hard to detect, in the sense that people asked questions and the LLM was answering correctly. And everyone's like, yay, it's working, we're good. Until we started running this harness. And then we started asking more table questions. And then we started saying like, oh, there's a problem here. There's a problem here. This thing happened like overnight, took a couple of days, to kind of like get to the point of like, what exactly is the problem? Why is he answering this person and he's not able to answer this one? And that's what the harness helped to reveal. So we had the bottleneck of the table data. And there were three culprits. The first one is encoding. Encoding. This is a problem from, I don't know what year but it's someone worked on this many years ago, but LLMs didn't know, right? They weren't good at that. So we had a problem with that. Also, the table structure gets lost. When LLM ingests the data in the RAG system, the structure of the table, it just messes it up somehow. So, and also sometimes we have, like for example, we had a document that had what you call a crest or a company seal, right? And then you throw that, you ingest that into your RAG, and it just kind of like hung up. The Go program died. I don't know what this is. So it took so long and didn't finish, and then we have to then also be like, if you find something you cannot, can you just keep that page? Because we're ingesting probably 20, 35 pages of documents, and in each of those documents we have probably some companies out like 5 documents. A company like Shopify, they've been around for more than 10 years. Every year since they went public, they've been filing all of these reports. You need to have like a full year, a half year, the Q1, Q2, Q3, Q4, because investors can ask any kind of question. Can you compare Q4 to Q4, Q3 to Q3? So lots of documents. So those were like the issues that this RS helped us to like define. Yeah, of course. What are we going to do when we find this kind of thing? We tell the LLM fix it. Right? Is anybody fixing code? Fix it. You found it and fix it. So we tell the LLM to fix it and did a pretty good job. Very likely article, but things good. So first of all, we have to do like ATL parser, the better one, to be able to like not lose that encoding. And all the gavel text, crest, icon, whatever that's in the document, that some nice people put there to make the document look pretty. Because the document wasn't built for agents, it was built for human. Right now, it's agents using the documents, so I would say that in the future, maybe there will be documents made for agents. Maybe when they publish their financials, it's like, this is the human copy, this is the AI copy. Something like that. Yeah, it won't be too far. So yeah, catch all the word boundaries, keep any corrupted page before you index, match the spacer cells in the table, try to figure out the HTML, and then make sure that it is correct after you read it again. So, and all of that, we put all of that in. And what was the result? we hit 95% on accuracy, which was also pretty surprising. Like, oh yeah, it's very good. So, and there was, another regression that almost slid off because for some reason, I the agent. The agent changed the temperature, changed it from 1 to 0.1 for some reason, for some weird reasons. And things started to fail. So, and the bottom line that I'm trying to say is, thank God we had the hands to find that, before we kind of like ask for the next round of test. So it was just like, oh, there's a regression and it's mysterious. We don't know why there's a regression. Then we found what the issue is, and we were able to move from 89% success to 95. The goal was 90, but we hit 95. Okay, 95 is pretty good. When we were if you had a 95%, you are good. You are the A. So that was how we kind of like just made it to that point. And at that point, we had enough confidence to be like, okay, yes, we can ship. We can ship this to production. We can give it to customers to start to use. And and that has happened. And they're pretty happy with it. So far, working for us, yeah, paying customers and all of that. Good for them. Good for the agent too. So this was the result after the fixes. Either 90% overall. The table questions went from 60 to 89 based on the ability to have an honest account point. What makes a good eval test case? So this is from experimenting and trying different things out. So we found that one concept per question is just good. There were times that we combined questions together, but we wanted to make sure they were in the same concept. We wanted to think the way investors would think. Someone that actually wants to invest in the company, they're thinking about what's their EPS, what's the dilution, what's going to happen to this company. Do they have a future? Are they going to what's happening in the industry? So then also, if you have like the sources, because you want your agent to be accurate, so you want to like include like the sources. Excuse me, the tolerance, we have to be exact for numbers. Like I said, you cannot allow 1 million to go to 2 million. It's just not acceptable in this domain. And also semantics for like analysis. There are like multi-hop reason questions, like the example I gave when you say, if I bought Google shares 10 years ago, what would I make by now? If that's a multi-hop reasoning, it needs to do that. All of the share prices, do some calculation, and then also recheck. So we have that instruction in the prompt to always reevaluate your answer, see if it makes sense. And you have to choose between latency and reasoning. Because every time you send things over to LLMs, it takes a lot of time for the response to come back. For the last response. So we have to move to what we call streaming. I believe everybody has been streaming. Nobody's waiting for LLM response again. As long as the first character is available, we're good to go. So streaming, and also just balancing the categories, to say that, make sure that when we do the agents, we go around different kinds of questions. That's when we can have the confidence that this agent really works. Otherwise, there's a risk that you might break in production. Let's build the eval before you optimize. You can write the code before you build the eval, that's okay. But before you start like optimizing, you should have an eval in place. It could be a small one. It doesn't have to be like super complex. And then the test cases should like be categorized. You can run like eval again and again and again and get different results. But we want to make sure that to an extent we have confidence in the system. Also, eval can catch a lot of bugs so far in what we've seen, especially in this regard. So those are the things we learned. Now let's talk about the cost per eval. And this is where it gets interesting. And I'm sure you all have heard of a concept called token max. Everybody has heard of token max? It means that please blow all the tokens that you need to blow. Nobody cares. That's the definition. So I know companies where they're like competing on who spends most of it. the CTO spent $3,000 in 1 month. Yay! I'm in the company. So, but anyway, so you can run this eval, but it costs half a dollar to run. Now this can wrap up very quickly in cost. So what we'll do here is not to run the eval. We don't want to run the eval like RCI, so that every time you push the code, the eval runs. That's the best thing to do, but it can go pretty expensive. So we can do a couple of things here. Go to like the test and make sure that they don't run on every merge. And you can like trigger them if you want to run them. That's like one way. If you make changes to your prompt, which is like the main instruction, you want to try running the eval to be sure that nothing has drifted too much. So otherwise, 20 questions to the agent, about 0.1 to 0.3. Then we use like a cheaper model for the LLM-as-a-Judge. There are also many other ways to like reduce your costs. Like for example, running this eval, you don't want to use like an expensive model. So you want to stay with Composer, smaller models. If you have a beast of a machine, you could run it locally. It's gonna be slow, but it's okay. It's an eval. You can run it and go somewhere and then come back. 2 hours if we're done something. But for the cost of inference is really nothing compared to the cost of failure. When you think about it. Because if your agent breaks in production, that's a repetition risk. A lot of things could go wrong. But if you spend $50, $100, $1,000 to make sure your agents work correctly, still fair in the context of a production system. So then, so I wanted to also mention tools and frameworks, some of things that I use personally. There's a framework called it's a Golang framework written by the parent company of TikTok, or Prometheus. So they released this framework it's been a couple, I don't remember exactly where you can check right there. It's a pretty good framework. This is the lang chain of code. I've been looking for something like that. At some point, I thought I was going to build one. It was too much work. Then I came about this. So very great framework. It's got lots of all the piping that you want to do within an agent. It's got the graph movement where your agents can. It has like React as well, where your agents can like reason. And it's all like already piped in a way. It does streaming as well. So I like recommend this. If you're reading like LLM agents, you can check it out. It's got a couple of also something like human in the loop, where you can actually pause an agent and resume it back. Maybe on trigger. For example, if you're reading an agent and saying things like plan a flight for me from here to Toronto on the 30th. You need to check the flight, you get the dates, then it needs a human approval. It's like tap. So it's still going to be the same agent, it's just going to pause. And you're going to resubmit when the user gets approached. So pretty good framework. Then there's another tool called Langfuse. Langfuse is like the telemetry layer. You can plug into your LLMs as well, your AI agent. It's pretty simple to set up. They have like SDKs, just AI key. 3 lines, you're done. And what that does, I should have got the description. So what that does is it kind of helps you track the life cycle of your request. You can see what your agent does step by step. If you have like multiple actions, you can see how long each one of those calls take. The example that I gave in this project, we have database query. Remember I said we didn't put the actual numbers, we're stored in tables. So we have a context, we have a query, we have the API call to the LLMs, we have the reasoning that happens after all of that. So we can see the whole trace. When the call started, the first call, the response that came back, then he did a reasoning, decided to make another call. We can see all of that. So very, very useful. I recommend Langfuse. And the last thing there is a library that I wrote and open sourced it just in the course of this project. And this is just something for SEDA. SEDA is like US stock repository. It's got all the documents in like the public stock exchange, and it's free. So I did find like a library that was in Python. Using LLMs all these days. Change it to Go. Right? And then I did a code review, lost the code review. Now in code review. But did the work, so I was able to just then when I was done, I was like, okay, yeah, maybe someday somebody wants to build an application that does the same thing. So this is like a good library that really like does all the abstraction. You just call it, get the data you're looking for. So yeah, so these are like my recommendation. There is one more that I did not hatch with, and those are like still pretty new. A2A protocol, which is agent to agent, and A2UI. A2UI is an interesting paradigm where the UI can be dynamic. We all use like text UI, right? It's agents, but you can have like dynamic UI. You can have generated charts, just from the back end. So interesting stuff that I would encourage you to like try it out. But yeah, these are good frameworks that I found very useful. So what's next? You can do a CI integration, but they might be of cost. Trends we can like try to determine, and also like adversarial cases, which is where you're actually asking very bad questions to the agent deliberately to make the agent fail. That's also important. Because people will do that. People will ask complex questions, confusing questions. It's just what we do. Multi-domain eval, you can ask the same questions across different domain, and also like latency. So how long does this take? When we go over the wire and we send requests to where is OpenAI data center? San Francisco. And then we go like all the way, it goes through downtown. And then it comes back and it takes 17 seconds. We want to track that. We want to make sure that it's not getting worse over time as well. So key takeaway, if you're building with LLMs and you don't have an eval, you're flying blind. The LLM will work. I'm sure it's going to work. But what we need is for it to work all the time, and in all cases. Maybe not 100%, but at least 90% of the time. We know that LLMs are hallucinated already. Everybody put it in their disclaimer. This is LLM generated. You can make mistakes, that's fine. But there are some mistakes that are more costly than some mistakes. So we want to try to eliminate those. It took 1 afternoon to build the annex, but it caught bugs that weeks of manual testing actually needs. So, it's a good topic to talk about in this event. That's it. Thank you so much for the time and the audience. That's all from me. Thank you. So, okay, question. Thank you. Yeah, it should.
So I wanted to ask about your threshold. You said 0.7 is a pass, below 0.7 isn't a pass. Did you just pick that number, or did you find a lot of questions that were passing, were getting scores? I don't know how you came with that. And do you find different types of questions have different thresholds, maybe, or what do you know about that?
Okay, yeah, that's a good one. In my experiment, the goal we're looking for is 1.0. That's like the goal. Theoretically, but we want to go as best as we can to make sure the answer is correct. So in cases where we've done like 0.5, 0.6, you might get like half of the question correct and half wrong. In which case we still consider it wrong. It's like saying like the share of Google is $1, but you would have made X amount of money if you bought last year. Like it's still incorrect, even though some have might. So that's kind of like okay. And that number, we just chose them. There wasn't like we didn't consider like any framework or any published data. It was just the local testing to be like, okay, we want to aim for 1.0, but if it's below 0.7, I'll be interested in to see that answer. I want a human to read it and let's know if it's actually correct. So yeah, that was how we kind of came with it. There is no preference. Okay, thank you. Yes.
Quick question from my side. So I hope probably expected questions and these answers hard-coded or the value in these answers could be changed. Because, for example, like the stock price, it's one stock price today and it's different stock price tomorrow.
Yeah, that's a great question. So the questions were actually in the JSON file and the answers for determinants or things that were determined. For example, the full year revenue 2024 will never change, right? So that's like a constant. That's like all I'm doing. But for like a question that says, if I invested 10 years ago in Google, how much would I have made? We need to check the current stock price. That also doesn't move like that much in the day. So yeah. So as long as in the trace, we can see what the current stock price is. We want to make sure that that is correct. And as long as it goes to the source where we ask it to fetch the correct source price from, we're pretty confident that that's fine. Because we know the source, we trust the source where the data is coming from. We just want to make sure the LLM make that call and got the data from there. So then, based on that, you can, so it's a mix of data. But if you have like anything that's like determinate, it's already like passed, it cannot change, you can just code them in the JSON. That should be completely fine. But anything that's like dynamic, you want to like use and see if it's correct.
And one more question. So this test that you showed us, this pass rate 95%.
Yeah.
I'm wondering if you came across this situation when tests are passing at 95%, but customers can play with something.
Yeah. Yeah. We have cases where we've seen customers complain that maybe the answer is not impressive. Like the answer is correct, but I don't like the way he told me. And that's very relative. There's really nothing much you can do about that. And if you like change your prompt, adjust the temperature, the swing in the effect is always too much. Because if you just change from if you just modify your prompts, your AI can just start messing up. Just because of that change. Or if you just move from one model to the other, everything just changes. So yeah, we've seen that cases. But if our eval is 90, 95, we're pretty confident it works for the most part. It works for most of the users. Like if it works for 95% of the users, see that 5%, we're just going to tell them, we're sorry, try again. And most times when they try again, they're like, oh, now I like this one. And it's very hard to be able to model what people expect because everybody expects different things, right? So if we do our ML and we're like, yeah, this is working for the general population, we're pretty confident that we can ship it. And that doesn't mean it's not going to break in the future. If you change model, it's going to break. If you change temperature, it's going to break. So all of those things, they're regression buckets that you have to be more careful of when making just swing changes. I hope that answered a little bit.
Yeah, and one more last question on my side. So I'm wondering what kind of metrics and maybe logs you will use to make sure that everything works fine in prod. This kind of LLMs, things, and just make sure that everything works.
Yeah. So they're basic. This is basic production setup that I always recommend. It doesn't matter 10 users, 5 users. If you're running something in production, you should have lots. You should have a structured log. That you can pipe into something, turn into Grafana. So we have the setup we have Grafana, we have Loki, that passes the data. We have Prometheus as well. So we have like charts and graphs, and you can see how things are going, at least relatively from 10,000 feet. And if we do find something, we want to dig into logs a little bit more. So yeah, if you have like just this basic, these are pretty good open source tools, that you can use to set up like your system. Grafana is pretty great for me, pretty does the job. The graphs and then the metrics and then through time. You can actually see like live logs, and just watch the logs. And then if you have, then also like, of course, you're doing like a structured logging so that you can like filter those logs, search from the log easily. If you're looking for like a particular thing, you can look for it. And also when like in the code, we also want to be very structured in our logging so that we want to know when the agent, we want to know what the agent is doing. Doing like step, we have like very good step names. So that we're saying step, this is the name of the step, this is the next one, and it just goes like that. So that if you take a look at the log, you can kind of like see the reasoning and the flow of the LLMs. And Langfuse that I mentioned is also very useful. Yeah, every LLM calls Langfuse. So very, very useful. Yeah, that's good. Thanks. Thank you. Okay, yeah, sure.
Did you guys ever try doing anything like for the responses? I guess they're generated every time somebody asks. So if somebody asks, like, I want the report for Google from Q3 to Q3 of these 2 years, whatever. Are you guys caching any of those responses? So if somebody asks a similar question, like let's say something happens with Tesla and a bunch of people are asking all the same questions about Tesla, like you already have those values kind of cached by, I don't know, semantics of what they're looking up and then returning those values, or did you just, it's better to just do it every time kind of thing?
Yeah, that's a good question. We do cache, but what we cache majorly is the context. Because the context about a company will not always change. Google is a search company founded by Sergey and Larry Page. All of those kind of things will always be the same. So we kind of cache those ones, just put them in context. We use Redis. It was actually local Redis. So that because you have to optimize for like every millisecond. So but like every other data that has to do with like real-time information, we never cache that. And then every financials, those were already stored in tables. We didn't cache that, we just stored them in tables. Yeah. So, and then one thing you can do is also what they call prompt caching. If a couple of LLMs providers support it, OpenAI does. There's another one called Mercury. Mercury is like another model. Mercury also does support prompt caching, and is able to like take the prompt that you're setting again and again and just keep some of them if it's the same session. Yeah, but you really do have to be careful, because you don't want to, two people might be chatting at the same time, talking about the same company, but they have different goals. So you don't want to like mix match the data at all. So we do like a session caching so that for this particular session, this is like the cache that's two for the conversation to happen. And we do record like all the conversation. So every single thing that the customer said, even if they do abuse the LLM, every single thing. Just it's a very good learning point, but you can then go back and say, okay, how did this conversation go? And then we do also have something that's like a thumbs up, where they can actually rate a conversation. So that also becomes like some kind of feedback to know whether they enjoyed the conversation or it's just a mess. So yeah. All right. Okay, thank you very, very much. It's my honor. Thanks so much for the opportunity.
Thank you.